This is my task 1, prediction using decision tree algorithm for the Spark Foundation July 24 batch. So here I'm predicting the species of iris using decision tree algorithm. We are provided with a data set of around 150 samples, the features being sepal length in centimeter, sepal width in centimeter, petal length and petal width in centimeter. Based on these 4 features, we are predicting the species of iris. So to start with, I'm importing the required libraries, pandas, plotting, Seaborn for plotting, matplotlib for plotting, then the decision tree classifier, train test split for splitting the data into train and test, confusion matrix and confusion matrix display for model evaluation, and accuracy score for seeing the performance metrics. First, I will load the CSV file which is provided. This is the data set using Panda. I will read the CSV file. Print the total number of samples. Here, the total number of samples is 150. I'll just view around 10 rows of the data set just to have an idea how the data looks like. Now I'll do some exploratory data analysis. Using isNull.sum, I'll see if there are any null values in the features. Here we don't have any null values. We all have values in all the rows. I'll plot a pie chart to see how the data is distributed in the species. So we have 50 exact images for Iris setosa, 50 for virginica and 50 for versicolor. So it's equally distributed around the 3 species. I'll see the correlation between the features. For correlation, we don't need to have the columns ID and species. We just need the 4 features. So using that as a data frame, I'm plotting the correlation matrix. The blue color means it's negatively correlated or it's low correlation, and towards red it is highly correlated. So as you can see, sepal length is negatively correlated with sepal width, but it has a very positive correlation with petal length and petal width. Sepal width at the same time, it is negatively correlated with all the other 3 features, 3 features. Then petal length. Petal length is very highly correlated with all the other 3 features. Petal width is also correlated with other features except for sepal width. Now to check if we have any outliers, I am plotting the box plot. Here the median lies in between around the center of the box, which means the data is evenly distributed. So this is the first quartile, second quartile and third quartile. These are the whiskers. So if you see sepal width, we have some data which falls outside the whiskers. So these are the outliers. So we have some outliers in sepal width. So now to train the data, we don't need the first column ID. This is just a unique reference ID for the rows. So we can drop the column ID and we are using the remaining values for training. So this is the updated data set. Now for training purposes, we are taking the first 4 features except the species column and saving it in x_data. Then for the label, we are taking the last column, which is species. This is what we are going to predict. So the features are sepal length, sepal width, petal length and petal width, and the target is species. Now the entire data set we are splitting into train and test using train test split with a ratio 0.2. That is 80-20. 80% of the whole data will be for training and 20% will be for testing. So if you see, the number of training samples is 120 and testing samples is 30. Next, we are instantiating the decision tree classifier, and we'll feed the X-train and Y-train, the training data, into the model and fit the model with the training data. After the training is completed, a message is printed saying the training is completed using the classifier. Now we are using the same model which is already fitted with the training data to predict the test data. So we use predict function and give the test features to the model, and we get the predicted values. Y-test are the actual values which we already have. Using this Y-test and the actual values and the predicted values, we display the confusion matrix. The confusion matrix shows the true label and the predicted label. So in this case, all the instances of Iris setosa are predicted as Iris setosa. Similarly for versicolor and virginica. So we don't have any false positives or false negatives here. So if you print the accuracy of the model using accuracy score, it is 100% in this case, which means all the test instances are correctly classified and the model is working perfectly fine after the performance evaluation. Thank you.